Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hi class, welcome back to SIC2003 Physical Chemistry Lab. Today we're going to continue with our discussion on an experiment. And today's experiment is on experiment 5, which is the partial molar properties of solutions. Now, partial molar property is a thermodynamic quantity which indicates how an extensive property of a solution or mixture varies with changes in the molar composition of the mixture at constant temperature and pressure. So the extensive property, which depends on the mass of the property that we are going to discuss today, is the partial molar volume, is the volume, right? Which is the extensive property that we're going to talk about. So this partial molar volume, Vj for example, of a substance J, and the contribution J makes to the total volume of a mixture. So 1 mole of a characteristic volume, when it is pure, can make different contributions to the total volume of a mixture due to the molecular packing in such a way that it will be different in its pure when it's in its individual pure states or when it is in a mixture. So the gist of this experiment is to say that often the total volume of a solution is not simply the sum of the volumes of the components. So the partial molar volume of the components will allow one to correct for this difference. Okay, so a classic example to introduce this concept is when 1 mole of water is added to a large pool of pure water, the increment in volume will be 18 cubic centimeter. But if you add 1 mole of water to a large pool of ethanol, the volume increases by only 14 cubic cm. So in other words, this 18 cubic centimeter per mole is known as the partial molar volume of water in pure water, whereas the 14 cubic centimeter per mole is known as the partial molar volume of water in pure ethanol. And the latter is due to that there's so much ethanol in water that each water molecule is surrounded by ethanol molecules, so the packing of the molecules results in the water only occupying 14 cubic centimeter. So in general, the partial molar volume of a substance X in a mixture is a change in volume per mole of X added to the mixture. So, and these partial molar volumes of components of mixture will vary with the composition of the mixture due to the environment of the molecules in the mixture changes with the composition. Experimental wise, you're going to prepare 2%, 4%, 8%, 12%, and 16% weight by weight sodium chloride. And you'll be using a pygnometer to determine the accurate density of solution. Now this is a pygnometer, which is probably the cutest glassware you ever seen in the lab. So one day when things are better, when we are allowed to go back to the university, you can go to the second year lab and take a look at how a pygnometer is. Okay, so this is a pygnometer, so it is used to measure the accurate to measure accurately the density of a solution. So before you can use it to measure the density of sodium chloride solution, so first you have to determine the volume of the pygnometer. Now although you'll be using a 25 ml pygnometer, but you can't just trust on the label here. You need to accurately measure the volume. In order to do that, you will use a famous solvent, which is water, to actually determine this what do you call this, volume. All right, so with first, of course, you measure the mass of an empty pygnometer, add water, so you know the volume of the mass of the water. So on top of that, you need to also do a air buoyancy correction, which you will also see in the lab manual, because that could also contribute to inaccuracy of this density. So the whole point of using pygnometer is to make sure that everything is accurate. So you have to also cater for this air buoyancy correction. Once you have done that, based on the temperature of the ambience, the temperature of the lab, so there's a thermometer on the wall. You can actually, there's a reference book there where you can look at the temperature and find the corresponding density of water. So you have now the mass and the density, so you now can measure the volume of this pygnometer. Once this volume is calculated, is determined, then you can use that to find the density for this sodium chloride solution once you have measured the mass and so on. Now when that is done, okay, so you will use those values to calculate the molality, which is mole of solute against the mass of the solution, and that is symbolized by small m subscript b of each solution, and determine the apparent volume of the solute for each molality. Now this apparent volume is described as apparent because it appears to represent the molar property of that component in solution, provided that the other conditions remain constant. Okay, so this is a given data for you. So these are the sodium chloride at different concentration. Okay, different concentrations, and the number of moles of distilled water is given, number of moles of NaCl. These are all calculated, and the molality is also calculated. Okay, and this is done after air buoyancy correction. So the other thing that is also given, the room temperature is at 23.5, and based on this temperature, the density of water is found to be this. All right, and the apparent molar volume is given by this equation, which is found also in your lab manual. Okay, and so everything is given, the density of water, you have the molality, and this is the density of each of the solution. That's the molar mass of NaCl, and that's rho, which is there. So all you have to do is find the square root of the molality and also find the apparent molar volume based on the equations given. Okay, now so what you have to do is, with those data, okay, plot the apparent molar volume of NaCl versus the square root of molality. From there, calculate the partial molar volume of water, partial molar volume of sodium chloride, and also the total volume of the solution. Okay, and this calculation is by using the equations below, the following equation, which is this. Now these are all given, so this is the gradient of the plot that you'll be plotting. So from the gradient, so you get this value. All right, and this is the molar volume for the pure solution. Okay, so which is water. So you can actually use all the values that's given to do that. Right. So once you have done that, this is another data you have to fill in. So what's the partial molar volume of all this at different concentrations? So when you get this, so clearly there is a trend that you will see. So this is what you need to describe in the in your discussion. All right. So as usual, the report contains all this: the completed calculations and plot, brief discussion of your results, references, and this will be due next week on the 10th and submitted here. All right, so that's it for today's experiment. So I'll see you next week for the next experiment. So thank you and take care. Assalamualaikum.